question is, if I have a triangle, how do I solve? Apart from the time they will ask you to calculate for the area, perimeter, and all of that for the triangle, right? These are the formulas that you're going to apply to solve triangles. First question you ask when you have a triangle is, what kind of triangle is it? Are you with me? Is it a right angle triangle or not? If it's a right angle triangle, you either solve by what? By Pythagoras theorem, or you solve by what?
Trigonometric ratio.
And then we have an acronym for trigonometric ratios. The first three, we use what now? Solve at what? That's what we're going to explain this better later. I always say that sine what now? Sine of an angle is equal to what? Opposite of what? Hypotenuse. And then we say that what now? The cos of an angle, the cosine of an angle is what now? It's adjacent over what? Hypotenuse. And then we say that what? The tangent of an angle is equal to what now?
Opposite over adjacent.
Over adjacent. Alright? This is what the shortcuts one mean. SOH, CAH, and TO what now? These are the first three what? Trigonometric ratios. There are others. But these are what now? The prominent ones. Is that okay? Is that alright? Then if the triangle is not a right angle triangle, we either solve by what? Sine rule, or by what? Cosine rule. Sine rule, or by what now? Cosine rule. Now, let's try Pythagoras theorem. What do I have here? It's a right angle what? Triangle. If all you are given are the sides of the triangle, if what the calculation is involved is just the side of the triangle, or the right angle triangle, what you think about is what? Pythagoras what? Theorem. And the relationship for what? The three sides of the right angle triangle is what? C squared equal to what? A squared plus what? B squared. If you are looking for the longest side, the square of the longest side will be the sum of the square of the other two what now? Sides. If you are looking for any of the other side, the longest side here is C, right? The one facing the right angle what? The right angle. Are you getting what I'm trying to say? If you are looking for any other side, it's going to be what? This minus what? Minus this. Are you with me? Then if you're looking for, let's say B or B squared, so the C squared minus what? Minus A squared. Are you with me? Are you know what I'm saying? If I'm looking for the longest side, it's going to be sum of the other two squares. If I'm looking for any other side, it's going to be the square of the longest side minus what now? The square of the other side. Are you with me? So this one is for what now? Pythagoras what? Theorem. When all three sides are what? Are involved. Then if what? If an angle is involved, the game what? Changes. Are you with me? It changes. This is A, this is B, this is C, right? This is A, this is B, and this is C. For this triangle, I've told you before now, that we cannot tell the side that is what? That is opposite. Is that right? Be careful so you don't disrupt what we are doing. Careful. Right? So we have A, B, and what? C. Also have A, B, and what? C. What is the name of the side C? Hypotenuse. The side C is what now? Hypotenuse. Side A is what? Side B is what? As long as no angle is given, both sides are what now? Adjacent. But when a side and angle is included, the game changes, right? If, for example, I give you this angle, what will happen? Why this side will still be what? Adjacent. This side becomes what now? Opposite. You get what I'm saying? So this side becomes what now? Opposite. However, if it is this angle that is given, are you with me? This side becomes what now? Opposite. And this side becomes what? Adjacent. Which side does not change? The hypotenuse doesn't what now? Doesn't change. Are you getting that? Hypotenuse doesn't what now? Change. So what do we do for trig ratios? We have said for similar triangles earlier on that what? If we have similar triangles, the ratio of corresponding sides will be what now? Equal. If the ratio we are having for any two similar triangle, hello? The ratio we are having for any two similar triangle remains opposite to what? To adjacent. Sorry. opposite to hypotenuse. What we're talking about, the name of that ratio is called what now? Sine. So if I'm doing sine theta, I must be involving what? Opposite and what? Hypotenuse. Alright? And we know the one. Please don't get distracted. Just pay attention. Hello? We know that sine what now? Like I said there, sine theta is what? Opposite on what? Hypotenuse. That's even why they are called trigonometric ratios. Because the cos or cosine of an angle gives you what? The relationship between what? Adjacent and what? Hypotenuse. If it's the tangent of the angle I'm looking for, it's going to give me what now? The relationship between what? Opposite over what now? Adjacent. Now I'm going to try and buttress this a little further. Is that right? Okay. For these triangles I want to show to you now, right? This side here is what? Opposite, am I right? I need the response. Here's what? Opposite. Here's what? Hypotenuse. And here's what? Adjacent. Here's what? Opposite. Here's what? Hypotenuse. And here's what now? Adjacent. Here's what now? Opposite. Here's what? Hypotenuse. Sorry, adjacent. And here's what? Hypotenuse. I've been able to establish that these triangles are what? Are similar. What is similar? Here's what? 30. Here's what now? 90. And here's what? 60. Since their angles are the same, and the ratio of their corresponding sides are what now? The same. Because if you check here, what do I have here? If I'm doing opposite over hypotenuse, all I have. Opposite over hypotenuse. For the first one is what? Is what now? 2 over what? Over 4. Am I right? And 2 over 4 is what? 0.5. For the second one is what? Quickly. 4 over 8. And 4 over 8 is what? 0.5. And then what now?
8 plus 16.
8 over what? 16. Which is the what? 0.5. I get what I'm saying? So mathematicians now agree that what? That this ratio of opposite over hypotenuse for any set of similar triangles should be called what now? Sine. So if you go and check for sine what? Sine 30 degrees in your calculator anywhere in the world, all you get what now? 0.5. Do you understand? Sine 30 degrees for any what now? Any right angle triangle should give you what? 0.5. That means any triangle you see that the sine is 30 degrees, it means that the opposite will be what now? Half of what? The hypotenuse. For any triangle at all, that the angle is what? 30 degrees. Do you understand what I'm trying to say? If it's 30 degrees that you are seeing in the right angle triangle, the hypotenuse must be 2 times bigger than what now? The opposite. And they say let us call this ratio what now? Sine. Do you get what I'm saying? That's how this one came to be. Now, if we are comparing, help me very quickly. If we are comparing adjacent over what? Hypotenuse. What they say we should call this ratio? Cos. Check very well. What do I have adjacent here? I have what? 2 root 3 over what? Over 4. And that's going to give you what? 0.866 something, right? Yes. Now if you check for this one, you get what now? 4 what? Root 3 over what? Over 8. 4 means you get what now? 0.86666. You understand what I'm saying? If you try for the other one, you get what now? The same thing. So now they say that should be what now? Cos what? Cos 30. That should be the value of cos what now? Cos 30 degrees. You get what I'm saying? So anytime we're having a ratio of what? Adjacent over what? Hypotenuse. It becomes what now? Cos. Do you understand? And the ratio is what? The ratio is what? Opposite over what? Adjacent. What do we call it? We call it what now? Tan. Is that right? That is how we came to have, for the trig ratios, that SOHCAHTOA stuff I talked about earlier on, is what? Sine of the angle to be opposite over what? Hypotenuse. Cos, right? Cos of the angle is the ratio of what? Adjacent over what? Hypotenuse. And then what now? Tan of the angle is the ratio of what? Opposite over what? Adjacent. We have laid a foundation for right angle triangles. In the next class, we'll pick it off from what now? From other triangles. You have the sine of an angle, sine rule and what now? Cosine. Is that okay? you can go to your class.